Howdy, howdy. Welcome to another edition of Dinosaur Parkour. Faster, better mainframe programming. The topic for this video is variable QSAM. What is the RDW, or Record Descriptor Word? I'm your host, Chris P. Fried. This slide gives information about the environment upon which I've tested. IBM Enterprise COBOL 6.3, running on a Z14, ZOS is 2.4, ISPF is 7.4. RDW stands for Record Descriptor Word. It is a full word that tells the length of a variable QSAM record. QSAM files are sometimes called flat files. QSAM stands for Queued Sequential Access Method. This video assumes the records are blocked. This shows fixed versus variable records that have been blocked. The pink or the salmon color represents a block of records. The top block contains fixed length records. Every record is the same size. There are 9 records in that block. The block size is a multiple of the record size. For example, 10 80-byte records fit in a block that is 800 bytes. A block of 800 is too small. The ideal block size for a 3390 DASI device is 27,998. So the goal is to get as close to that as possible without going over. Therefore, the ideal block size for an 80-byte record is 27,920 bytes. For the variable block, the ideal block size is 27,998. Since the records are varying in size, the number of records that fit in the block also varies. 7 records are shown fitting in this block. Record number 4 is very short, and that record could fit at the end, but the other records are too big to fit in the space that remains. So if the program was writing record 4 again, it would fit at the end. But if the program was writing any of the other records, again, they would not fit. The RDW is 4 bytes long. At my prior shop, some of the assembly programmers called it the LLBB. You can find a couple of hits when using Google to search QSAM LLBB. I like LLBB because it always helped me remember how the record descriptor word is formatted. LL is the logical length. I'm not exactly sure what the BB stands for. It might stand for block byte. The record descriptor word is 4 bytes long. It is divided into 2 half words, LL and BB. LL is the logical length of the record. According to the IBM manual, the LL can have a value of 4 to 32,760. 4 means there's no data. Using ISPF edit, I was unable to create a record without at least 1 byte of data. I also attempted to allocate a variable file with an L record equal to 4 and got a message that the file was invalid. I was able to allocate a variable QSAM file with an L record of 5, which is 4 bytes for the record descriptor word and 1 byte of data. So the shortest LL for my quick and dirty test was 5. As stated earlier, I don't know what BB stands for. When coding a similar, I was told byte byte or binary 0 because those 2 bytes are almost always binary 0. If the value of the BB is non-zero, it is used to control span record. A span record is a record that is longer than 32,760 bytes. Therefore, it takes 2 or more blocks to hold a record. Variable record 1 has a data length of 24. The phrase "the data for this record is 24 characters, including the spaces." The record descriptor word contains the length, including the record descriptor word. The record descriptor word is 4 bytes, so the LL portion of the record descriptor word contains 24 bytes of data plus 4 for the RDW equals 28. The LL portion of the record descriptor word is a binary half word. 28 converted to hatch is 0H1C or hatch 001C when expressed as a COBOL literal. The third record has a data length of 34 bytes plus 4, so it's 38, or hatch 0026. The sixth record has a data length of 10 bytes plus 4, which is 14, or hatch 000E. In the upper left corner is a field labeled the BDW. This stands for the block descriptor word. It tells the system the size of the block. From an application perspective, it is controlled behind the scenes. It is extremely rare for an application person to care about it. Use the dataset panel or 3.2 to allocate a test file. From the ISPF main menu, select 3 for utilities and then 2 for dataset. We want to allocate a variable block QSAM file. LREC will equal 4096. Therefore, the data portion is 4092. Leave the block size 0 or blank it out. I prefer to blank it out. This tells the system to hit the optimal block size. Same thing for directory block. I prefer to blank that out. Provide face attribute per your normal methods. When you invoke the information action on the dataset, you should have something similar to this. The odds are high that the device type is 3390. On the allocation panel, it was advised to leave the block size as 0 or to blank it out. The reason for doing this is so that the system picks the optimal block size for the device type. For a 3390 DASI device, the ideal block size is 27,998 for a variable block file, and this is regardless of the LREC size. The organization is PS for physical sequential, so this is a QSAM file. The record format is BB for variable block. Use edit to add a few test records and enter save on the command line to save the record. This shows test records I have created. Notice the line / record number on the left side. There are 17 lines or records in this file. Exit the edit. Browse the file. Not view mode, but browse mode. My preferred way to enter browse is to use option 3.4, which is DS list or dataset list, to list the dataset, followed by placing a B for browse beside the desired dataset. When you enter the browse panel, it likely shows the same thing you saw while in edit. The major difference in appearance is that the line counter on the left side is missing. Therefore, we're able to see a few more characters for record 6. On the command line, enter display RDW. That changes the display to hatch mode and shows the RDW for each record. On the screen, record number 5 is at the top. Notice the scroll in the upper right. It is CSR, which means cursor control. By placing the cursor on line 5 and pressing the page up key, record 5 was moved to the top of the display. Record number 5 is 9 characters or 9 bytes long. The LL portion of the record descriptor word contains hatch 000D, which is 13. The RDW is 4 bytes, so 9 characters plus the length of the RDW is 13. The LL portion of the RDW for record 6 contains 00AD. When hatch mode is on, the hatch lines are red, top down, left to right. The first byte is 00, and the second byte is AD. The entire LL portion of the record descriptor word is 00AD. You can use a programming calculator However, a quick way to get the decimal value for hex 00AD is to use Google. Enter 0xAD, 2 decimal, in the search bar and press enter. For me, Google returned a calculator image that shows the decimal result as being 173. That is the length, including the RDW. The length of the data is 169, or 173 minus 4. The next record shows this. The length is 5, but the data is a single byte, the exclamation mark. So 5 minus 4 equals 1. The record with the data 1, 2, 3, 4, 5 has a length of 9, and the last record, which is 6 characters, is going to be 6 plus 4, which is 10. 10 decimal is hex A, or hex 000A. On the command line, enter call, COLS, for column and press enter. Move line 6 to the top, scroll to the right, or you can enter right 110 on the command line to move 110 positions to the right. The top portion shows the column with the RDW turned on. Notice that line 6 ends in position 173. Display RDW and COLS are really useful when building sort control cards. The bottom part of the slide shows COLS with no RDW. Notice that the last character is now 169. If you're using no RDW to build sort control cards for a variable file, remember to add 4 to each field. For example, the word jump on the no RDW screen at the bottom, jump starts in position 145. 145 plus 4 equals 149. Glancing at the top part of the screen, which has display RDW turned on, the word jump starts in position 149. So there you have it. That is the record descriptor word in a nutshell and one way to view it. Thank you for listening. I'm your host, Chris P. Fried. Dinosaur Parkour, faster, better mainframe programming.